Hello everyone. Welcome to another interesting session of your favorite YouTube channel, My Project Ideas. We are working on the DSA course and today's topic is trailing zeros in a factorial. In the last lecture, I already told you what are factorials and we wrote some very interesting codes. Then we found out the efficient algorithm as well. We learned about factorial. But in this lecture, we'll be moving a step further. We'll be learning the trailing zeros in a factorial. So first a question might pop up in your mind that what is a trailing zero, because you know what are factorials. But what do I mean by trailing zeros? So a trailing zero means basically the zero which appears at the end of a number after you find out the factorial. Suppose for an example, you have a number 8. I have given you a number 8 and I ask you to find out the trailing zeros, number of trailing zeros in the factorial of 8. So first your job is to find out the factorial of 8. So it's 8 into 7 into 6 into 5 up to 1. The answer you get is 40320 and the number of trailing zeros is 1. Got it? Next. So I have given here three inputs. Input is 5, 20 and 100. Just don't look at the answer and comment down your answers, your take on the number of trailing zeros if I give you the input 5, 20 and 100. Nothing to do. Just find out the factorial of 5, find out the factorial of 20 and find out the factorial of 100. See, you cannot find out the factorial of 100 manually. So write down a code. Like I told you in the last lecture how to write the code of the factorial. Write down the code. You will get the answer of 100, the input 100 and then calculate the number of trailing zeros. Okay. I hope you have done this small task. Now, what are the approaches that we are going to work on? We are going to work on two approaches. One is naive approach and one is efficient approach. So what is naive approach? Naive approach is basically a layman approach, which is not efficient, which everybody does. So what is a naive approach? Simple method. First calculate the factorial of n, then count the number of trailing zeros. And normally everyone will think of this. But this approach has a problem. Factorial of a number can be very big at some times. Like if I tell you to calculate the factorial of 100, it can be very, very, very long. And this can create overflow. Okay. So it's a bit of a problem. For that reason, we are learning DSA, right? So let's find out the efficient approach. How do you do? So you know that a zero can be formed by the factors of 2 and 5 because 2 multiplied by 5 is 10. So a factor of, like, suppose 4, the number 4. 2 is a factor of 4 and the number 25. 5 is a factor of 25, so 4 into 25 is 100, produced some trailing zeros. So if there are more factors of 2 than 5 in n factorial, the number of zeros will be determined by the number of times 5 is a factor of the number, because 5 is very crucial while you want to calculate or while you want to get a zero in the number. So how do you calculate the number of 5s? So count how many multiples of 5 are there in the range 1 to n. First, in the range 1 to n, if you have a number n, just find out that how many multiples of 5 are there in that number. So count the higher power. So the simple trick is count the higher powers of 5, like 25, 125, because every number which is a power of 5 will contribute some other factors of 5 or some additional factors of 5, some like some more numbers of 5. So it will give more number of trailing zeros. So I know it was a bit tough. Don't worry. Look at this example. It will be very clear to you. Suppose I have given you a number n, which is 100. What do you need to do? First divide 100 by 5. So you get 20. So you got 20 factors of 5. Then what you have to do? Divide 100 by 25. That is higher power of 5. You get 4. But if you divide it by 125, it will not contribute anything because it will exceed 100. So 100 by 125 will come in decimal. So 20 plus 24 will be 20 plus 4 will give rise to 24. Got it? So now we'll have a look at the code. Before that, I think I have done some spelling error here. Okay, issues. Simple, right? You can figure out that. We are done. Then let's have a look at the code. Here I have made a separate file for you to find out the trailing zero. See, before I write the code, do one thing. You just try to write down the code by yourself and jot down your code in the comment section. And let's have a look how many of you are actually with me in this. So, okay, we are writing it in Python. So first, let's define a function. Find trailing zero, and we take a number n as input. If n is less than 0, this is basically a negative number case. Okay, so we return -1. Then we do the count. See, in Python, indentation is very important. Very, very important. Count is equal to 0. You have to write the indentation very carefully. Then while n divided by I is greater than equal to 1. Let's go inside the loop. I think I'm doing it right. Okay. Then let's increment the count variable. Then because we are finding out the factors of 5, let's check factors of 5. After which we return count. Because I told you that we are working on the factors of 5. So higher factors of 5. I gave you the example. Now let's move to the main function. Move to the next line. Indentation is perfect. If write down the function name is double equal to main. These things are clear to you, right? Nothing big deal. Main. This is basically my driver code. Okay. Then n is equal to suppose 100. I have to print the trailing zeros of 100. So let me write down a printing statement. Count of trailing zeros in, put a comma here, n, let me put a comma here, n, because we are finding out the number of trailing zeros in n, factorial. So let me write down a factorial here. Then is, and we'll return a function. Find trailing zeros. Find trailing zero, and in this we give a n as your input. Okay, I hope you're good to go. Let's run it. So it says count of trailing zeros in 100 is 20. So I hope you understood the working of this code. For more interesting project ideas, stay tuned to this channel. Thank you and have a great day and happy learning.